students, today we are going to discuss chapter 7 alternating current. Before starting the chapter alternating current, let us find out what is direct current and what is alternating current. Direct current, you have already studied. A current which do not change its direction with time is called direct current. Current which do not change direction with time, it is called as direct current. It is also called as unidirectional. Unidirectional means does not change direction with time. Or you can say a current does not change sign with time. Sign with time means the current, it is either in the positive side, only at the positive side, or only at the negative side. That is called direct current. If we draw the graph for direct current, I versus T, this line represents direct current. But direct current does not mean that it is a constant current. It may be a current whose value is changing, but it is only at one side, so it is also direct current. Direct current we can obtain from DC source, direct current source, and that you are knowing DC source as a cell or a battery. Battery means combination of cells. So cell, battery, they provide us direct current. But in our house, office, industries, everywhere we are having alternating voltage and alternating current. So what is alternating current? A current which changes its direction with time. It is called as alternating current. Current which changes its direction with time, that we can show by the graph. This is a current and this is time on x-axis, since it is independent. Now the current, alternating current, it is having both positive value as well as negative value. Or we can say alternating current changes its sign. Sometime it is positive, sometime it is negative. It can be shown in another way also, the current and time. It might be like this. This graph was sinusoidal curve and this is a square wave. This way also you can show. Or you can show current accordingly like this also. This might be the value of current which is changing with time. And this is known as alternating current. What is the source of alternating current? Alternating voltage is the source of alternating current. How we can show the source of alternating current? The source of alternating current is alternating voltage, which is called as AC voltage. Which is called as AC voltage, and it is shown by the sinusoidal S. That means it is changing the current, it is changing its sign with time. That is called as alternating current. Alternating voltage, that is called as a AC voltage. Alternating voltage we can see everywhere, as in your own house or shops, everywhere you will see, industries, commercial complexes, everywhere we are having AC voltage. So what is the AC voltage? A voltage which varies sinusoidally or like a sine function which varies with time. That is called as a AC voltage. Or you can say AC voltage which changes with time, which varies with time, it is a AC voltage. You can see AC voltages are preferred over a DC voltage. Everywhere we see AC voltage. it is preferred. There are some reasons why AC voltage is preferred. Conversion of one voltage to another. That means conversion of higher voltage to lower voltage, or from lower voltage to higher voltage we can do easily with the help of transformer if we are having AC voltage. The second reason is that the electrical energy which get transmitted from the power stations up to the application site, it can easily transferred with less power loss if we are having AC voltage. If DC voltage is there, power loss will be greater. That we have seen earlier also in third chapter. And one more advantage of AC voltage is that we can easily design the AC circuits according to our applications. So AC voltages are preferred over DC voltages. Now students, we are going to learn a simple circuit in which we are having AC voltage. The simple circuit is AC voltage applied to a resistor. In this circuit, here we are having AC voltage which is connected with a resistance R. This R resistance is constant in the circuit. Here AC voltage is shown by S, that is a sinusoidally varying voltage, and here this AC voltage produces sinusoidally varying potential difference across the terminals. Current I is flowing through this circuit. Here I have written small I. Small I represent the sinusoidally varying current, alternating current. Here, let us consider the AC voltage which we have applied in the circuit. It is given by V equal to Vm sin omega t. V equal to Vm sin omega t. What is Vm? Vm is the maximum amplitude of the sinusoidal voltage. Vm is the maximum amplitude of the sinusoidal voltage, and omega is called angular frequency. Omega is called angular frequency. And here omega t is the angle, or you can say omega t represent here the phase. Here it represents the phase. Now we are applying Kirchhoff's loop rule to this given circuit. As you know, in the Kirchhoff's loop rule, summation change in the potential over the closed loop, it is equal to 0. Change in the potential delta IR, it is equal to 0. So applying it, we are having a voltage Vm sin omega t minus IR, it is equal to 0. Vm sin omega t minus IR equal to 0. So Vm sin omega t equal to IR. So we can write Vm upon R equal to Vm upon R sin omega t equal to I. Here R is a constant, so we can write I maximum. Vm upon R we are writing as I maximum sin omega t equal to I, and this we are referring as our equation 2. When you will observe the equation 1, which is for our AC voltage, which produces a AC current, alternating current, and if you observe both the equation, the phase in the both equations it is same. If we draw the graph of these two equations, current and voltage varying with time, current and voltage both varying with time. So here I am having a graph like a sine wave, because you see the equation for voltage Vm sin omega t, it is varying sinusoidally. See the current equation, it is also varying sinusoidally, and you can see that the maximum amplitude of current is smaller than maximum amplitude of voltage. This is represented by Vm and this is Im. This graph shows that the current and the voltage, they achieve minimum, maximum, zero, all the values at at the same time. V maximum and I maximum. This is V maximum. This is I maximum. They achieve at the same time. 0. The 0 achieved by the current and 0 achieved by the voltage. It is also at the same time. Minimum. Minimum achieved. Minimum value of current and minimum value of voltage. It is also at the same time. So we can say that when the voltage and current, they both achieve minimum, maximum and 0 value at the same time, then we can say that this voltage and current, they both are in the same phase. They both are in the same phase. Here one more time I want to give emphasis on the amplitude of voltage and amplitude of current. V maximum upon R gives us I maximum. And due to that I maximum, the current which we get due to this potential difference, due to this AC voltage, will have a amplitude smaller than the potential, smaller than the voltage. Students, we have seen the graph of voltage, AC voltage and AC current with time t. Both are sinusoidally varying, both are achieving maximum, minimum, 0 at the same time, so they both are in the same phase. As you can see, the current and the voltage, they are getting the positive values and same corresponding negative values they are getting in a one complete cycle. Whatever value of positive current is there, same negative value of current is there in one complete cycle. AC voltage and AC current, they both vary sinusoidally, and due to that the sum of instantaneous current over a complete cycle will become equal to 0. Whatever positive values of current are there, same negative values of current are also there. So sum of instantaneous current over a complete cycle will become equal to 0. I instantaneous equal to 0. But it does not mean that power average is 0. P average is not equal to 0. Why? Why it is not equal to 0? As you know, the power dissipation or the joule setting, it is given by I square R. Here we are not having the term I, but we are having I square. So whatever the negative values, they also get squared and added there. Now, P instantaneous we can write by putting the value of I square, I maximum square sin square omega t R. That means I maximum square R sin square omega t. This is P instantaneous. That means power instantaneous. Let us find out what is P average. P average is given by P and over a bar for average, or it is written in a bracket. Bracket also represent average. I square R, because P is given by I square R. Substituting the value of I maximum square R sin square omega t. The current I maximum square and R, they are constant. They have taken outside, and we want to find out the average of sin square omega t over a complete cycle. Now we are using the mathematical formula sin square omega t. It is equal to 1 minus cos 2 omega t upon 2. Sin square omega t 1 minus cos 2 omega t upon 2. Let us substitute here. We are finding out P average. So I maximum square R in average bracket 1 minus cos 2 omega t upon 2. Let us take outside these 2. So it will become I maximum square R upon 2. Average of 1 minus cos 2 omega t. As you can see, 1 is a constant. We want to find out average of cos 2 omega t over a complete cycle. Complete cycle means time from 0 to t. T capital T, time period. So how to find out average of cos 2 omega t? Here we are taking 1 by t integration cos 2 omega t from 0 to t dt. Integral cos, it is sine, you are knowing. So 1 upon t sine 2 omega t, and the limits are 0 to t upon 2 omega. Now we have to substitute the value of limits. So let us substitute it. Here 1 by t outside as it is. We have taken outside 2 omega. Inside we are having sine 2 omega, and at the place of t we are putting upper limit capital T. And when you are putting 0, it will become 0. You might be remembering the value of t. T is 2 pi by omega. So let us write here at the place of t 2 pi by omega. 2 pi by omega. So omega will get cancelled out. What we are having? Sine 4 pi. And the value of sine 4 pi is 0. So the average of cos 2 omega t over a complete cycle will become equal to 0. So now we are substituting this in our equation. P average. P average, P and a bar over it. P average. So P average equal to I square, I maximum square R upon 2. Because as we have seen, the average of cos 2 omega t, it is equal to 0. Here we got the average equal to 0. Average of cos 2 omega t, it is equal to 0. So P average is I maximum square R upon 2. As we have seen, average power AC is I maximum square R upon 2. What is power DC? Power DC is I square R. By looking at both the equation, you can see that IRMS, root mean square current, which is used in AC, it is also written as I, and it is nothing but I maximum upon root 2. Root 2, 1 upon root 2, its value is 0.707 I maximum. So IRMS, that is root mean square current, is I maximum upon root 2, that is 0.707 I maximum. When we draw the graph of AC current with time, it is a sinusoidal curve, and as you see, this is the maximum value of current. So where will be the IRMS? IRMS, it is 0.707 times I maximum. So IRMS is here. That is also written as I. Now VRMS, similarly we can write as a V maximum upon root 2. V maximum upon root 2, 0.707 V maximum. As we have already written this equation earlier, if you remember, V maximum upon R equal to I maximum. So we can write V maximum equal to I maximum into R. But I maximum, what is I maximum? I root 2. I root 2. And V maximum is V root 2. So V root 2 equal to I root 2 into R. We are getting V equal to IR, which is same like a DC equation. V equal to IR. In our house, we are having AC voltage of 220 volt. What is the peak amplitude of that voltage? And peak amplitude of that voltage is obtained by V maximum equal to V root 2. That is 0.707 into 220. You will get 311 volt. That is the peak magnitude of the voltage which we receive at our home. Power in DC, it is written as P equal to I square R. Here we have seen, if we are having a simple circuit where the AC voltage is connected to a resistor, we got the same relation, V equal to IR. Here also we will get the same equation for P. It is I square R. I square, this I is nothing but IRMS. It is same as VI and it can be written as V square upon R. It can also be written as V square upon R. So thus we have discussed today the AC voltage source. When it is connected to the resistor, the current, AC current and the voltage, they both are in the same phase, and the value of current which we obtain, it is I maximum sin omega t. The current and voltage, they receive maximum and minimum value at the same time. So they both are in the same phase, and power average we obtain as I square R.